So here again we come with the question number 2. Let's go through the question. For any n greater than equal to 2, that's a positive integer, the integers 1, 2, 3 are written on the board. I'll not write right now. Let's understand the question. In a move, Alice can pick two integers written on the board, a and b, with a is not equal to b important, such that a plus b is an even number. That means either they both are even, they both are odd, and erase both a and b and replace it by a plus b by 2, the mean. Find all n for which Alice can make a sequence of moves, whatever be, so that she ends up with only one number remaining in the board. For example, for 1, 2, 3, it's not there. So we will attempt this problem in 3 steps. 1 is the initial cases to understand what is happening. So n is equal to 1 is obviously true, n is equal to 2 is false, n is equal to 3 is false, already mentioned in the example. N is equal to 4, if you try for that, it is 1, 2, 3, 4, and obviously the only possibility is 1 plus 3 by 2, 2, 2, 4, and 2 plus 4, 6 by 3. So you don't move further. So n is equal to 4 is not possible. N is equal to 5, 1, 2, 3, 4, 5. I begin with 1 and 3, make it 2, 2, 4, 5. Then I start with 2 and 4, so make it 2, 3, 5. Then we have to but obviously work on 5 and 3, so this makes it 2, 4, and this is 3. So the mid value 5 is okay. N is equal to 6. Can we comment directly that n is equal to 6 is not possible? The answer is yes. Think through for a moment. Why can we directly make a statement that n is equal to 6 is not possible? Why I have taken initial few values? So that we understand the trend. Now we break this entire problem into 2 cases, when n is odd and when n is even. Let's begin with n is odd. 1, 2, 3, dot, 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 2n plus 1. Our objective is to reduce to one number, and there is no particular algorithmic thought process which we can devise initially unless until we understand what is happening. So we start with the way we tried in, we can of course try in 7 also. We start with 1 and 3, make it 2, 2, and here of course the last 3 terms would be 2n minus 1, 2n, and this way. So if I take these 2, this will again become 2n. So I have 2 2n's. And start clubbing them together like this. So we realize that it is on a particular note possible to reach to a number n plus 1, which is the median of this sequence. The big question is, why should I believe that this is true for every n odd? In fact, we would not be in a very better position to do inductive reasoning also, because the moment I try it for 7 and go for 9, it is not the same sequences that will work. So it has make a sequence. So some sequence works that way. So we will have to do is, we will have to do it for general proceeding and then show that it ends up in n plus 1. For n is even, the challenge is even a little bigger. You cannot simply make it one go. So we make the even numbers in 2 form. Either it is 4m or 4m plus 2, because here it is easy for us to show how this progresses. Now suppose it is 4m. We have seen that for 4m n is equal to 4, it's not possible. So we should ideally look for 8, or for that matter 1, 2, 3 up to 4m. And once again we start pairing, keeping in mind that we do not lose out, and if we can show that particular structure which is easy to show, then for 4m plus 2 it is possible. The challenge here is, why I am not doing exhaustively, that if you have to show it with some logic, then this proof will not work. Then you will have to devise some working, but which absolutely is not possible, because the number of sequence or the pattern of sequence changes with the number. So we will have to relate with m and n so that it doesn't go haywire. This once written becomes easy. If you want, we can go ahead with 2 plus 4 by 2, so it's 2, 3, 5. Then here we can try with this one, so this becomes 2n minus 1, 2n. So suddenly we realize that our sequence has become a smaller sequence, and if this way we proceed, we reach to n plus 1. The same has to be done here. The question is undoubtedly tricky, understandable. The answer remains that for any n greater than equal to 7, all are possible. The not possible cases are 2, 3, 4 and 6. Now beyond 7 and 8, how do we allow us to understand that this is possible? So the current situation says that this is the only approach by which we reduce to a smaller consecutive number, then further. We may not call this induction because it is not going inductively, it going successively.